Hi guys, welcome to Learn Max Easily channel. Now we are going to see the continuation of the lesson matrices class 12. Our next topic into the accordance is types of matrices. So there are totally 7 types of matrices present, which we discuss each one by one, right? The first one is column matrix. What is a column? It's nothing but like this, right? Representing numbers in the column wise, right? Like this. So they are given an example like 0 root 3 minus 1 1 by 2. In column matrix there will be only one column present. The definition states that a matrix is said to be column matrix if it has only one column in it. It can be of, the length can be n. It can be of n number of numbers can be present inside the column matrix, but only one column. So this matrix is said to be column matrix, right? These general things are to be known so as to continue the exercise further, right? What is the row matrix? So as I told, representing like this is column matrix. Vice versa, the opposite like this, representing the matrix like this will be the row matrix. This is column matrix, this is row matrix, right? Yes, this can be of any numbers, row matrix 1 2 3 dot dot dot, like this. Representing like this comes to as a row matrix, and representing like this comes as column matrix. So in column matrix they generally represent the matrix in the form of m cross 1, where m stands for the column and the m stands for the number of amount that is present, that is rows, right? So this that is x y z number of rows, and 1 stands for only single column, right? Generally in matrix it is nothing but row cross column. We can easily remember nothing but in column matrix it is nothing but m cross 1, because in column matrix only one column is present. So 1 n number of rows or m number of rows, it can be matter, no problem, we can just put m or n over here. So it states the number of items that is present, number of elements present inside the column matrix. So it is generally represented as m cross 1. This is for column matrix. Similarly for row matrix, generally as I said, it's vice versa, it is 1 cross n, right? Okay, here again n stands for number of elements present inside the matrix. These are two types of matrices. Now what is the third type that is present? It is square matrix. Now they have given an example like this: 3 minus 1 0, 3 by 2 4, 3 minus 1 1, 3 root 2. Now they have given an example like this, and it is a square matrix of order 3, or it can be generally represented as 3 is generally represented as m or n, whatever it is, no problem, right? It's our assumption. Here the number of columns, that is 3, number of rows is also 3. So when, wait a minute, yes, when the rows and columns are equal in length, then that matrix is called as square matrix. I repeat, when the column length and rows length are equal, it is called a square matrix, right? Now the fourth type of matrix is diagonal matrix. Okay, when a matrix is said to be a diagonal matrix, now going to see about the diagonal matrix, we have to consider again a square matrix. As I told you over here, the square matrix where the number of columns should be equal to number of length, as I told you. So they are considering a 2 cross 2 matrix, say for example -1 2, over here 0 0. When a matrix is said to be diagonal matrix, if its non-diagonal elements are 0, right? Non-diagonal elements are 0, then it is said to be a diagonal matrix. So again they are given one more example. This is a 2 by 2 matrix. Now for a 3 by 3 matrix, it will be more easy for you to understand what is generally a diagonal matrix mean. Now this is a diagonal numbers present in the matrix, and even this too, right? Now in this diagonal matrix, now see, these portions are not coming under the diagonal present, so that numbers are 0, that elements are 0. So diagonal matrix states that a square matrix is said to be a diagonal matrix if its non-diagonal elements are 0. These are the non-diagonal elements. Non-diagonal elements means the elements that doesn't come inside the diagonal elements. These are the diagonal elements, right? This is the diagonal of the matrix. These elements does not enter into this diagonal path, so this is said to be a diagonal matrix because they are 0, right? So again over here, zeros. The diagonal is this one. This is a 0, this is 0. So this is again a diagonal matrix of 2 cross 2 matrix, and this is a diagonal matrix of 3 cross 3 matrix. So this is the diagonal matrix. When a diagonal matrix has become like scalar, next topic scalar matrix. When a diagonal matrix has equal elements in its diagonal. I repeat, when a diagonal matrix has equal elements in its diagonal, right? What I told you, this will be the same. This will be anything else. This diagonal should be same irrespective of these things. So then it is said to be a diagonal element, right? Yes. Now this also 0. Yes. 0 0 0 0 0 0. This numbers, whatever it may be, if it is present like this, then it's a diagonal elements. When this diagonal elements constitute the same numbers, say for example 2 alone, right, or 1, whatever it may be, 2 2 2, then this matrix is called as scalar matrix. I repeat, 0, 0, -1, 2. Example of diagonal matrix. Because the diagonal has elements and the rest part is 0. In scalar matrix, the same thing, irrespective of that is the rest of the elements are 0, but the diagonal elements are same. This is different, this is same. This is diagonal matrix, this is scalar matrix. That's the difference. But both that is equally shares the same condition, but one extra condition is present to the scalar matrix. That is nothing but this same element should be present in the diagonal. That's it. Then it forms a scalar matrix, right? And you can also say like this, right? Every scalar matrix is a diagonal matrix, but not every diagonal matrix is a scalar matrix, right? Then what is identity matrix? Again, the name suggests identity is nothing but 1, right? Again, 1, 1, 0, 0. This is identity matrix. When the diagonal elements are 1 and the rest of the elements are 0, then it forms a identity matrix. So again, we can say that every identity matrix is a diagonal matrix, but not every diagonal matrix is an identity matrix. So for 2 by 2 matrix, there is only one identity matrix, that is nothing but 1, 0, 0, 1, or either way, right? 0, 1, I'm sorry, 1, 0. Yeah, only possible it's these two ways, right? So again, for 3 by 3 matrix, 3 cross 3 matrix, 1, 1, 1, 0, 0, 0, 0, 0, 0. This is again 3 cross 3 matrix and identity matrix. The diagonal elements is only 1, right? You cannot put 2 or 3 everywhere and make it as an identity matrix. Now it becomes a scalar matrix or a diagonal matrix, but only one should be present, then it comes as an unity matrix, that is identity matrix, right? These are the types of matrix. They are general representation, which is more important for you to just move on with the next topics that is present in this chapter, right? Then what is the zero matrix that is present? As the name suggests, zero matrix is nothing but the entire value present inside the matrix will be 0, nothing but 0, 0, 0, 0. 2 by 2 matrix, then 0, 0, 0, 0, 0, 0, 0, 0, 0. Yes, 3 by 3 matrix. Whatever the matrix, whatever the that is m and n value may be, everything will be 0. So that is 0 matrix. Now the next they are given is equality of matrix. They are given an example like this: 2, 0, 3, 1 and 2, 0, 3, 1. Now these both matrices are equal because the first position, that is A11 of this matrix and the A11 of this matrix are same. Similarly, A12 are same, A21 are same, A22 are same. So when you are writing, what we have to write is nothing but it is there in the textbook. What are going to write like A11 of the matrix is equal to the A11 of the another matrix that is present, or you can name it as B11, right? Then A12 is equal to B12, A21 equal to B21, A22 is equal to B22. So by this way, both the matrix that is given are equal. Hence, that is nothing but the equality of matrix. It is the same case for 2 by 2 matrix, 3 by 3 matrix, whatever it may be. The elements that is present correspondingly to the next, that is to the next matrix, right? The same corresponding elements must be equal. Then that both matrices are said to be equal. With this equality property, we are going to find the values of x, y, z that is being further asked in the examples and your exercise problems. Example number 4. If the matrix given is equal to the equality matrix that is given in the next right hand side RHS, find the values of a, b, c, x, y and z. Okay, the same thing which I told you. The position of the elements in the left matrix must be equated to the position of the elements present in the right matrix. Say for example, in left hand side it is given as x plus 3. Right side in that same position of the matrix it's given as 0. So x plus 3 is equal to 0. So x is nothing but minus 3. Just equate what are the elements present in the left hand side of the matrix to the right side of the matrix of same position. Just mind that position, it's more important, right? Now z plus 4 is equal to 6. Obviously z will be 2. Such a simple question these things are. Then a minus 1 equal to minus 3. So a will be equal to minus 2. Then b minus 3, right? Oh, b minus 3. Okay. A small step is be needed to solve b minus 3. So a gap is needed. B minus 3 is equal to 2b plus 4. So what happens? B minus 7 equal to 2b. B equal to minus 7. Right? Yes. So x, y, a, b, similarly equating the z we get z equal to 2. Again we saw x as minus 3, y as minus 5, then a as minus 2, b to be minus 7, c will be again equating with respect to left side and right side. 2c plus 2 equal to 0. So all on the whole c equal to minus 1. A, B, C, X, Y, Z, right? The everything which they have asked is been found out by merely equating the left terms and right terms with respect to the position of both the matrices, right? Yes. Such a simple questions in these exercise or in this lesson are these things, and this is most basic things which should be known so further solving the problems present.